By now, you've likely seen the heartbreaking images coming out of Mississippi, where a violent tornado swept up cars, leveled homes, and tore apart an entire community.
Search and rescue!
And in the aftermath of this event, many of us are probably wondering, did climate change play a part in this deadly storm?
We can't link that individual event or even a series of maybe individual events 3 in a row to anything but bad luck at this point.
He'll explain why in just a second, but that's Dr. Victor Gensini, and he studies supercells.
These are the storms that have the rotating updrafts, very likely to produce large hail and tornadoes.
Supercells can spawn some of the deadliest weather, like the 2011 super outbreak, the Joplin, Missouri tornado that same year, the Moore, Oklahoma tornado in 2013, and more recently, the Rolling Fork, Mississippi tornado. And while that specific event can be linked to climate change, he has noticed a difference in tornadoes over the last few decades.
The overall number of significant tornadoes across the United States, that is pretty flat. But what's not flat is where they are. In other words, increases in a place like Atlanta or Tupelo or Memphis in terms of the number of significant tornadoes through time, and actually a decrease in some areas of the Great Plains like Dallas-Fort Worth or Oklahoma City, where their trends, they still get a lot of tornadoes every year, but the trends through time have been downward.
Knowing that, what can we expect as we head into the future and into a warmer climate?
It's going to be hard to attribute an individual tornado specifically to climate change.
Scientists have been able to draw lines between a warming Earth and things like hurricanes and heat waves by recreating these events in climate models. It's pretty much a very expensive version of Sims. Basically, they create these alternative versions of our world, mess around with how much carbon dioxide and other gases are in the atmosphere, and recreate a hurricane or heat wave under those conditions, just to see what happens. But it's trickier to do that with tornadoes because they're relatively smaller in size. And they're also very short-lived, lasting anywhere from a few seconds to a few hours, as opposed to days or weeks at a time. And global climate models don't have a fine enough resolution to simulate them. Instead, scientists must try to predict how climate change affects the ingredients that support supercells.
And so we rely on these regional climate simulations to do that.
And by using the smaller regional computer models, it took him and his team over 2 years, running simulations, crunching the numbers to get this bigger picture. Kind of like a puzzle of what we can expect in a warmer future. So what did they find?
And essentially what happens is when you turn up CO2 inside of those models, you see an increase in the number of those supercells in a place like Atlanta or Memphis or Tupelo in the Mid-South, but also increase in their intensity. And we think that's due to the more vigorous updraft that future climate may support.
Not every supercell will produce a tornado, let alone a damaging one. However, we are increasing our risk by doing other things.
I like to look at this as sort of a probability issue. We have 2 die, and 1 die is climate change, and we're altering maybe a 5 to a 6 on that 1 die. The other die is human exposure and vulnerability, where we're changing a 5 to a 6 by increasing the size of our cities and increasing our exposure and footprint and vulnerability. And so any individual toss of the dice, we don't really know if that 12 that we get, for example, is a result of one or the other. But over a long sample size, we're pretty confident, right, that the number of these events these tornado disasters are gonna be increasing.
While we can't point to a specific event like the Rolling Fork disaster and say, yes, climate change, it does fit into a dangerous pattern scientists expect in the future, which is more tornado-producing storms in a region with more people and more vulnerability.